So we have sussed out, I think we're all getting quite good at the solving trig equations. Yes? Now, here comes a little bit of a spanner in the works. In that sometimes you may be asked to solve something that looks like this. Okay? So sine 2x plus cos x equals 0. Well, that's nothing like we've been looking at. Okay? For a start, it's got sine 2x and cos x in the same thing. So what we're actually going to do is we're going to find a way of rewriting these expressions. Okay? And to do that, we're going to use what we call trig identities. Now, in your formula booklet, there's a little section in the trig page. You may want to look at it. You don't have to, but it looks like this. Okay, so you don't need to learn these things because they're written there for you, but you just need to know how we're going to use them. So what it says is that tan theta is equal to sine divided by cos. So you can change something from being a tan theta, and you can just write sine theta over cos theta instead. Okay? This is a very common one, that cos squared theta plus sine squared theta equals 1. So if, for example, you wanted to find an expression for... Oh, shush now. So if you wanted to find an expression for... Oh, I should use theta. If you wanted to find an expression for sine squared theta, what could you say? Just rearrange this bad boy.
1 equals 1
Kettle.
minus cos squared theta.
1 minus cos squared theta. Yes, that's pretty straightforward. Yeah? And obviously vice versa. If we wanted cos squared theta, it would be 1 minus sine squared. All right, so we can use this and we can rearrange this. These are what we call double angle formulae. I don't think there's a surprise why. It's because we've got 2 theta instead of just theta. Okay, so that's a double angle. So instead of writing sine 2 theta, we can write 2 sine theta cos theta. Now, this one, the cos 2 theta, we've actually got 3 different options. We've got this option, or this option, or this option. All right? Now, you're not going to use all 3 of them. You're going to pick one. You're going to choose the best one. All right? So just be aware. They've saved space by writing them all in the same line, but you're only going to use one of them. Okay? Right. So let's go through an example. It says, first of all, express 2 cos squared theta. No, it's not theta at all. That's next. It says express 2 cos squared x plus sine x in terms of sine x only. Right, what we're going to do. So we want to, instead of saying 2 cos squared x plus sine x, I need to change this baby here to be sine instead. What do you think we can use to help us? Where?
Equals 1 minus 2 sine.
Now, be careful here. This says cos squared x, not cos 2x. Remember that this secretly means this, but they just put the squared sign in between. So it's not going to be this one. Oh, shush now. It's not going to be this one. Which one is it going to be?
The first one, isn't the cos squared one?
It's this stuff up here, yes? You happy with that?
What's the difference between identities and never mind. That was a dumb question.
Okay. So we're going to use this up here. So instead of writing cos squared x, I'm going to write 2 bracket, and perhaps I should use better colours. So the 2 is still in black. Instead of cos squared x, what am I going to write?
Cos x squared. Cos.
Remember up here, instead of cos squared x, I need to rearrange this.
Oh, 1 minus sin squared theta.
Good. Okay. So down here, instead of writing 2 cos squared x, I'm going to write 2 lots of
2 lots of sine and
no
1 minus sin squared x.
1 minus sine squared x. Yeah.
what does that say?
In the black.
Yeah, sine and
Sine x. It's just a question.
I was just checking.
Oh, you lot picky. Now, does everyone understand where we got these things from?
yeah.
Is there anyone sitting there going, oh, I don't want to tell that?
Me.
All right, so Skylar, why do you think I put that thing in blue? It's different, okay? That's the only thing that's different. What did this blue stuff say before I changed it to being in blue? What was it originally?
Cos 2x.
Cos squared x, yes? And so I was able to rewrite it because from up here, I rearranged this here. And I can rearrange this to say that cos squared is equal to 1 minus sine squared.
You put it to that because you're ending with the sine stuff.
Yes. Okay?
You got it.
So now what I've done, what I've been able to do here is now, instead of having causes and sines, I've just got sines. Yes? So it doesn't look nice, so what I'm going to do is expand it out. Okay? So I'm going to expand this out, and I'm going to get what? Don't rush.
2 minus 2 sin squared x and the rest.
Pres bx.
Thank you.
So part B says now solve the equation, blah blah, equals -1. Okay? So if it says solve the equation, blah blah, equals -1, the fact that it's part B of this same question means it's unlikely that I'm going to leave it as 2 cos squared x plus sine x equals -1.
Yes.
The likelihood is that I'm going to use what I've just written here in green to help me.
Yeah.
Okay? Are you all happy with that?
Yeah.
Because sometimes you're not so hot with the A to B
So we
connection.
just make that all equal 1.
So what we're going to do, so rather than write 2 cos squared x plus sine x equals -1, I'm actually instead going to write 2 minus 2 sine squared x plus sine x equals -1. Okay, so instead of what they've written in their question, I'm writing my answer to part A is equal to -1 instead. Now, you may find that in some questions, part A could be a show that question. Remember, we like show that questions because it gives us the correct answer. We know we're going on the right track. If they haven't got a show that question, which this one wasn't, they have to repeat this same expression here because otherwise they told you the answer to part A. Okay, does that make sense? So just be aware when they're A and B, you are supposed to connect them. All right. Now, here comes the fun part where I say to you, oh yes.
Okay, wait, why did you put sin? Isn't that supposed to be cause? All of them?
No, because remember we just rewrote it as this.
No, not that. No, that's not what we're talking about. We're talking about these. The B. Yeah.
We used the A for doing it in terms of sin.
Okay, that makes sense.
And then you know how we did it up here? You went on the word. I don't remember. Oh yeah, you did. You know how we changed so it's cause and it equals.
Yeah.
Like we rearranged it. So basically
I
that
know, but we're using
equals that. So that's why we replaced it. You know, so you would just use it.
I see where we are. Because it
Because
wanted
it's
to
equal.
have
Because it's equal.
Now, this, at this point here, we've got an expression, we've got a number, we've got a sine squared x, and we've got a sine x, and equals something else. Does this remind you about any other thing that we've done in maths in GCSE as well?
Yeah,
where we've got
still-
squared
so.
and something, what does it remind you of? The thingy. Yes, Jennifer!
You didn't give me a chance when you asked me. You were looking right at me too. That's not right.
All right, okay, so the idea is that we look at this and go, haha, I've got sine squared, sine, and some numbers, which is very similar to having quadratic equation, isn't it? Because we have x squared, a number, and some numbers. All right, so we are going to now treat this as though it is a quadratic equation. How do we solve quadratic equations? What must we always do first when we solve a quadratic equation? Equal zero. So we don't equal zero yet, okay? I would also suggest that we're also got a negative number in front of our sine square, which is never normally nice. Okay, so what I'm going to do is I'm going to actually shift all of these bad boys to be on the opposite side.
But isn't that just gonna make the other side negative?
No.
No, it just means that I'm going to have 0 here, and then I'm going to add 2 sine x to both sides. So I've got now 2 sine squared x, and then I'm going to have minus sine x, and then I've got to do take away 2 from both sides. So this is now going to become minus 3.
So why isn't the minus sign a problem there?
It's just that because this here was a negative, it's just not nice to try and solve it when you've got a negative.
Okay.
It's this negative here I was unhappy about.
You did negative 1 and minus 2.
Yes.
So by moving it to the other side, how does that make that negative 1 0?
It doesn't make it 0. It makes it. You just have to make one side 0.
Because if you so where does the negative 1 go?
It joined with this baby here.
Alright. Alright. So you just skip the step in between.
Not really.
I know.
Just
I know.
do step.
Yeah.
I did each. I did everything at once.
Negative 1 plus minus 2. I'm gonna just trust.
Remember, you're taking 2 from both sides, so this is positive. This is a positive 2, Lydia, yeah?
Yeah, I get the other. I don't use
All right, so we've got 2 sine squared x minus sine x minus 3 equals 0. Now, it may be at this point you want to say, hang on a minute, I'm going to say, instead of using the phrase sine x, I'm going to use the letter P. Doesn't really matter what you use. So this is now going to say 0 equals 2p squared minus p minus 3. Shh. Enough. So Shelby, what did I do here? That's because you were talking to Sarah.
Oh, I know.
Sarah, do you know what we did here?
It's a random number.
So I just randomly chose the letter P just to make it so I'm not writing sine x all the time. Remembering that this means sine x all squared. Alright, so now I've got a quadratic that we're used to factorizing. So factorizing is probably the easiest option.
Yeah.
So, remember how to factorize these? We multiply this and this.
Yeah.
So 2 multiplied by negative 3 gets negative 6. Yeah?
Why did you divide by sine x?
I didn't. I was just reminding you that this
Oh, so that's the same thing.
means this.
I was gonna say, don't do the same thing.
So 2 multiplied by negative 3 is negative 6. So we're trying to find 2 numbers that multiply to give negative 6. And they have to add to give negative 1. Which 2 numbers are we going to use to multiply to give negative 6 and add to give negative 1?
5, 3. One of them's gonna be negative.
One of them's got to be negative.
3.
Negative 3 and 2. No, negative 2 and 3.
Negative
3 and 2 is positive.
Okay, it's going to be negative 3 and positive 2 because, Skylar, this value when we add them has got to be negative 1, yeah? So we've got 0 equals 2p squared minus 3p plus 2p minus 3. We then cut it in half and we factorize each half. So p is common here. You have to factorize both sides. So what value has come out of the right-hand side bracket?
2p minus 3.
But what value has come to the front?
Oh, wow.
Has to be something. So what's the easiest thing to factorize we don't normally do?
Put a 1 in front.
A 1.
Oh.
Wait, what? Oh, we have to.
So that you have to factorize. So it has to be a 1 if you don't need to do any factorizing. So then we've got 0 equals p plus 1.
So the 1's kind of like imaginary, but not.
Yeah.
Can you go?
So that now means that we can say that p has to equal negative 1, because it's either this bracket is equal to 0, or p is equal to 3 over 2. Okay. Now, at this point, we now need to remember that we weren't solving p. What were we solving? Sine x. So we're going to put that back in. So we're saying that sine x is equal to negative 1, and sine x is equal to 3 over 2. Now, here's your recollection of your sine curve. What was the maximum value or minimum value of a sine curve? For the sine, where did it go up to and down
1,
to?
negative 1.
1 and negative 1. So what value is 3 over 2?
0.75.
1.5.
1.5. So is this possible?
No.
So at this point we say, this one's impossible. Okay? And all we need to do is to give the values when sine x is equal to negative 1. Now, we have to go back to the original question and check which interval they're looking at. They're looking at between 0 and 360. So when we've been solving any of these trig equations, remember we sketch our function. Where does our sine graph start? At 0 or 1?
1.
And 0.
And then up, down, down, up.
You know how to.
I was listening to you.
Okay, within that range, where is our graph equal to negative 1?
270.
At 2 and
270, yeah.
yeah, 270.
So x equals 270 is the only solution for this equation. All right, so this is a second example. We've got sine 2x this time, plus cos x equals 0. Now, when you're trying to solve trig equations, and if it was just sine 2x on its own, like we were doing last lesson, that's fine. But if it's with another term, we need to get rid of this sine 2x. That's not going to help us. We need to rewrite it somehow. So this is where we're going to go back to our trig identities. And there is only one option for sine 2 theta. You see that? So instead of writing sine 2x, we're going to write 2 sine x cos x. So we're using this, that identity. So we're writing 2 sine x cos x plus cos x equals 0. Okay? So we've used our identities to replace this expression here. So whenever there's a double angle, so like the 2x, you're going to get rid of it by using trig identities. Then you're going to look at this expression and say, uh-oh, this is different. I've still got a mixture of sine and cos. But what can we see about this first term and this second term? What do they both have? a cos x, yes? And when an expression has a repeated thing, what can we do to that expression? Factorize it. Okay, we can factorize it. So,
Just saying.
so I'm going to bring to the front cos x. And what would be in my bracket?
2 sin x and 1.
Plus 1. Alright, so that means that either cos x has to equal 0, or 2 sine x plus 1 has to equal 0. Normal rules when we get to this point. So let's rearrange this right hand side so we could do them both together. So if I rearrange this would become 2 sine x equals -1, yes? And then sine x equals -1/2. Now in this case, we're going to check our two solutions and say, are they both viable? Are they both, are they, oh my gosh, you know what I'm trying to say.
No.
Are they both possible? Are they both possible?
No.
Why not?
Because
Are they between 1 and -1?
Oh, sorry, my mind, yeah.
Yeah. Okay, so because this number is between 1 and -1, they're both possible. So now we've got to solve two different equations. So for this one, I'm going to draw my cos curve. 90, 180, 270, 360. One and -1. For this one, I'm going to draw my sine curve. 90, 180, 270, 360. 1 and -1. So for my cos curve, does it start at 0 or 1? 1, so it's at 1, 0, -1, 0, 1. And my sine curve starts at 0, yeah? So where is my cos x equal to 0? 90 and 270. And for this one, we need to find when sine x is equal to -1/2. So what do we do when we're solving this? Draw your horizontal line at -1/2. How do we find our first solution? Yep, and then use the calc. Yes. So we're going to rearrange and use the calc. So you'll find that's -30. So -30 was this value here, remember? So remember, it always gives you the one nearest the x-axis. The y-axis, sorry. So if this value here is 30, how am I going to know what these two numbers here are? 360 minus 30, good. And 180 plus 30, awesome. So this is going to be 210 and 330. Yeah, you all happy with that? And so we just double check what was our range between 0 and 360. So therefore we're going to have 90, 270, 210 and 330. There are 4 solutions.